Hi friends, welcome back to another video. So today I'll be explaining physics October-November 2015 paper 61. Question 1 states the class is investigating two different types of pendulum. Figure 1.1 and 1.2 show the apparatus used. So this is the figure 1.1 and this is the figure 1.2. So question A part 1 states on figure 1.1 measure the length L of the pendulum. So on figure 1.1 over here, you will use a ruler and calculate the length from this point to this dotted line, which is the center of the bob, and the length over here is 4.1 centimeter. We have to calculate the length up to 0.1 centimeter, because if we decrease the value by 0.1, this will you will lose some marks. So you have to write 4.1 centimeter. Then part 2 states explain briefly how you would measure the length L of the pendulum of the type shown in figure 1.1 as accurately as possible. So measure L from the top till center of the bob, touching the rule by looking perpendicularly at the scale. So this is what you will write in part 2. Then question B states a student adjusts the length L of the pendulum shown in figure 1.1 to be exactly 50 centimeter. She displaces the pendulum bob slightly and releases it so that it swings. She measures the time Ts for 20 complete oscillations of the pendulum. So part 1 states record the time Ts as shown in figure 1.3. So over here it is 28 seconds and 20 milliseconds. So we will write Ts is equal to 28.2 seconds. We don't have to write S, we have to write S, not SEC, because over here I have wrote SEC, which is wrong. We have to write only S. Then part 2 states calculate the period Ts of the pendulum. The period is the time for one complete oscillation. So we write 28.2, which we calculated in part 1, divided by the number of oscillations, which was given over here, 20 complete oscillations of the pendulum. So 28.2 divided by 20, which will be 1.41 S, not SEC. So we write S. Part 2 of question B states explain why measuring the time for 20 oscillations rather than for one oscillation gives a more accurate value for Ts. To make sure the result is as accurate as possible, it helps to measure the small time interval. So this is what we will write in part 3. Then question C states the pendulum shown in figure 1.2 is a 50 centimeter rule. The student displaces his pendulum slightly and releases it so that it swings. She measures the Tc for 20 complete oscillations for the pendulum. So this is the Tc, which is 23.2 seconds. Part 1 states state a precaution that you would take to ensure that the measurement of Tc is reliable. Repeat the experiment and take the average. So part 2 states calculate the period Tc of the pendulum. The period is the time for one complete oscillation. So over here we have the time for 20 oscillations, which is 23.2 seconds, and we have to calculate the time for one complete oscillation. So 23.2 divided by 20, which will be 1.16 seconds. So we'll write Tc is equal to 1.16 S. Then question D states a student suggests that Tc should be equal to Ts. State whether the results support this suggestion. Justify your answer by reference to the results. So the statement will be no, because students suggest that Tc should be equal to Ts, because there might be some experimental accuracy. So justification is the results are too different. They are beyond the limits of experimental accuracy, because this over here Tc is 1.6, whereas 1.16, whereas in previous we have 1.41 seconds. So the results are too different and they are beyond the limits of experimental accuracy. Then question E states, assume the length L of the first pendulum has been measured accurately at 50 centimeter and that the length of the strip that forms the second pendulum is exactly 50 centimeters. Suggest why it may not be correct to state that both pendulums have the same length. Sum of the length of the strip is above the pivot of the clamp. So this is what we will write in question E, that sum of the length of the strip is above the pivot of the clamp. Question 2 states the class is determining the resistance of a resistor. Figure 2.1 shows the circuit. So over here we have the power supply and resistor, voltmeter and an ampere. So this is the figure 2.1. Part A states a student places the sliding contacts C at a distance L from the end A of the resistance wire. She records the reading on the voltmeter. So part 1 states read the meter shown in figure 4.2. Record in table 2.1 this value of V for length L is equal to 100 centimeter. So over here we have the figure 2.2 with voltmeter and it is at just above 2, so which will be 2.2 because there are 4 marks between 2 and 3, so we'll divide 10 divided by 4 which will be 2.5, so we will write 2.2 and then over here ammeter which is right on 0.2, so the ammeter will be 0.2. so over here it is 100 centimeter is how many volts, which is 2.2, and then for part 2 it states read the meter shown in figure 2.3, record the current I, which is I is equal to 0.2 amps. Then question B states plot a graph of V divided by V y-axis against length per centimeter. Start both axes at the origin 0, 0. So this is the graph which will be drawn on the graph over here. And question C1 states determine the value of y of the intercept y on the y-axis. So over here closely here above 0.5 which is 0.6, 0.7 and 0.8, or you can do 0.9 due to some different reading over here. So over here I wrote 0.9 which is the y value. There will be a range of y intercept on the y-axis, so it will be from 0.8 to 1, so we will write 0.9. Then calculate the ratio V is divided by I. The value of I is in your answer in part A2. So y divided by I, which is 0.9 divided by 0.2, which will be 4.5. So the value, so over here we will write y divided by I is 4.5. Question 3 states the class is investigating the reflection using a plane mirror. So figure 3.1 shows the student's ray trace sheet. So over here we have the ray trace sheet, and question A states that student draws the MR to mark the position of the plane mirror. Then part 1 states draw a normal line to this line that passes through this center. Label normal NL. Label the point at which NL crosses MR with the letter A. So over here first we will draw a normal line that passes through the center. So over here this is a normal line which is passing through the center over here, and the point at which the light ray intersects the line ML, you will point this as A. Then II states draw the line 8 centimeter long for A from A at an angle of incidence I30 towards the normal below MR and to the left of the normal, label the end of the line B. So over here we will draw an angle of incidence which is over here and mark this point as, label it as B, and this is what we will do. Then question B states the student places a pin P1 at point P. He places a second pin P2 on the line AB. So over here first the student places a pin at P1 at point B, over here P1 B, and then another pin over here which is the P2, and we will mark this as P2. This is just for show. And then over here label a position X on line AB to show the suitable position for pin P2. So here we have put an X for the good position for P2. So this is what we will do for question B. Then question C states he views the images of the pin P1 and P2 from the direction indicated by the eye in figure 1.3. He places two pins P3 and P4 a suitable distance apart so that pins P3 and P4 and the images of P2 and P1 all appear exactly one behind the other. The position of P3 and P4 are shown in the figure. So over here they have already shown the position of the pin P3 and P4, so you will connect the line over here. So over here part 1 states draw the line joining the position P3 and P4, extend the line until it meets NL. So that is what I stated earlier, that we have to connect P4 and P3 together and draw a line towards the center of the line which is MR over here. So this is what we will do in part 1 of question C. Then part 2 states measure the angle R between NL and joining the position of P3 and P4. So we will use a protractor and measure the length from this angle of refraction, and which will be 32 degrees. Then question D states state 2 precautions that you would take in this experiment in order to obtain reliable readings. First is use a sharp pencil to draw a line, so this will increase the reliability of the readings. Then second is ensure mirror does not move, because if at starting if you draw this line with a mirror at this position and then after drawing this part the mirror moves, so this will interrupt the whole this experiment will not be effective. So then P3 and P4 will not be joining at P1 and P2, so make sure that the mirror does not move. So in question D we will write use a sharp pencil to draw a line and ensure mirror does not move. Then question E states a student has done this experiment very carefully, taking these precautions. She is disappointed to find that her line for the reflected ray is not exactly where she predicts from the theory. Suggest a practical reason for this. First is the thickness of the lines or pins and difficulty of lining up pins and images. So these are the practical reasons for question E. Question 4 states the class is investigating the cooling of water. Figure 4.1 shows the apparatus used. So this is thermometer and a water with the clamp holding the thermometer. Then part A states record the temperature coaster C of the cold water shown on the thermometer figure 4.2. So this is a thermometer placed in the beaker in figure 4.2, and so we have to record a temperature coaster C. So over here on the thermometer it is above 20 degrees and there it is also at second point after 20 degrees, so this means it is at 22 degrees. So coaster C will be 22 degrees Celsius. Then question B states a student pours 100 centimeter cube of hot water into a beaker. He records the temperature constant H of the hot water in the beaker. So the constant H of hot water temperature is 83 degrees Celsius. Then it states one precaution that you would take to ensure that the temperature reading is as reliable as possible. So first one is new thermometer at right angle, and second is stirring the water so that the temperature of the reading is so that temperature in the water is even throughout the water. Then question C states a student adds 100 centimeter cube of cold water to the hot water in the beaker. He records the temperature Qm of the mixture, which is 46 degrees. Calculate the average temperature Qa of the hot water and the cold water using the equation Qa costa A is equal to costa H plus costa C divided by 2. So over here costa H is 83 degrees and over here costa C is 22 degrees Celsius. So we will write 83 plus 23 divided by 2, which will be 52.5 degrees Celsius. So costa average is 52.5 degrees Celsius. Then question D states the student carried out this experiment carefully. He was expecting that the temperature Q costa M of the mixture would be the same as the average temperature costa A of the hot water and the cold water. So just two factors that could cause costa M and costa A to be different. First one is some heat is lost to the surroundings. Second is some heat may be lost to the surroundings. Same one. Then the second one is there may be a delay in taking the readings. So first is, I will repeat that. First one is some heating may be lost to the surroundings, and the second is there may be a delay in taking readings. Question E states figure 4.3 shows a measuring cylinder. Three students take the volume reading. Their readings are student 1 is 80 centimeter cube, student 2 is 79 centimeter cube, and student 3 is 78 centimeter cube. Then part 1 states state the correct reading. Correct reading is 78 centimeter cube. Part 2 states explain briefly the mistake made by one of the other students. So the most inaccurate reading is student 1 is inaccurate because he did not read scale at the right angle or he read the top of the meniscus. So this is what we will write in part 2 of question E. Question 5 states the class is doing a lens experiment. Figure 5.1 shows some of the apparatus used. So this is the apparatus used in figure 5.1. Question part A states describe a diagram to show how the apparatus shown in figure 5.1 is arranged for an experiment to determine the focal length of the lens. The laboratory bench is drawn for you. So here we have the laboratory bench, and part question B states the focal length of the lens is known to be approximately 15 centimeter. Suggest a suitable distance D between the illuminated object and the screen so that the well-focused image can be seen on the screen. So here we will calculate the length D, which is 50 centimeter, because over here it shows the focal length of the lens is known to be approximately 15 centimeter. So over here we have drawn a focal length from here to here, which is approximately 15 centimeter. So suitable distance between the with distance D between the illuminated object and the screen so that the well-focused image can be seen on the screen. So the total distance overall in the book, it is written the distance between the object and the screen should be 50 centimeters. So D will be 50 centimeter. Then question C states suggest two practical difficulties that may cause inaccuracy in the value of the focal length. If room is too bright, and the second is if lamp is too dim, difficulty in measuring the center of the lens. So these are the two practical difficulties for question C. Question D states figure 5.2 shows the shape of the illuminated object. In the space below, draw a diagram to show the focused image that you would expect to see on the screen. So first we will measure the length. Draw a point over here, which is from this point over here, and then we will measure the length from here to here, so that it should be the length over here should be equal to the length from here to here. Then you will measure the length from the center to the top of the triangle, and then measure this length, and so we'll draw the exact same height of this triangle over here, and this will be the triangle that will be drawn in question D, as same as figure 5.2. So this will be the final triangle.